Hi there. So in this video, we're going to look at complex numbers. You'll also notice in Blackboard that I provided you with a link to a video that talks about imaginary numbers, which are what our complex numbers are. I encourage you to at least watch maybe the first 2 minutes of that video because I always get the questions, what is a complex number? And I just really feel like that video does a nice job for simplifying it there in the first 2 minutes. It kind of shows you where it's at because in the complex plane and that sort of thing. So again, check out that video. First 2 minutes would be sufficient though. Okay. All right. So let's jump right in. You'll be simplifying radicals with complex numbers. So I just at the top here gave us another opportunity to remember how to simplify radicals before we go to complex numbers. So if you recall from before, back in Unit 1, when we were simplifying radicals, we always kept in mind our perfect squares. And so remember, our perfect squares are the numbers 4, 9, 16, 25, 36, 49, and so on. And remember, I'm generating this list for myself. 2 squared is 4, 3 squared is 9, 4 squared 16, 5 squared, 6 squared, 7 squared, and so on. I mean, I could continue on 100, 10 squared is 100, 11 squared is 121, okay, and so on. Your idea, though, when you're trying to simplify a radical is you're trying to find the highest number in this list that will divide evenly into your given number. So like, for example, when we see 48, okay, well, I know 16 will go into 48. And so we say, well, 48 then is the same as 16 times 3. And so then if you recall, whatever you can take the square root of comes outside the radical. So I have 4. Square root of 16, of course, is 4. And then I can't take the square root of 3, and 3 stays inside. You'll always know that you can stop here because remember, there's not a number in your list that will divide evenly into 3, so you're done, okay? If I move on over to letter B here, square root of 108. Let's say, for example, you don't see, oh, the 36 would go into this number. Let's say you started out with and you said, oh, let's do 4 times 27. Okay? Well, we know then the square root of 4 is 2, and then that leaves me with 27 inside. But again, ask yourself, is there a number in your list that will divide evenly into 27? And sure enough, it will, right? We can write 27 as 9 times 3. So now the square root of 9 is 3 times the 2 that's already sitting out here, so I have 6 square root of 3. So just wanted to remind you of that. If you need any help with simplifying radicals, please reach out to me and I can point you in the right direction, okay? I can provide you with some materials or point you in the right direction, okay? All right, so let's scoot on down then to the next piece. It says, let's consider the function y equals x squared plus 1 and find the zeros of that function. First of all, let's graph this function, okay? And we should be able to crank out a fairly decent graph here. Because think about it, y equals x squared, like I was mentioning in section 2.5, that last section, we should now know that y equals x squared, oh, that parent function, that's a parabola facing upward. And what does this plus 1 do? It takes that parabola and shifts it up 1 unit, right? Ugh, that's terrible. Let me try again. Sorry. Okay, that's a little bit better. Okay. And wants us to find the zeros of that function. And if you recall from previous section, well, to find the zeros, that's where you set your function equal to 0 and solve for x. So if we do that, then our first step would be, okay, we're going to subtract 1 from both sides, and then I would have x squared equals -1. Now to get x all by itself, I'm going to take the square root of both sides, and here's where the problem lies. We can't take the square root of a -1. That's what we've always said in prior lessons. However, now when we're introducing complex numbers, we actually can. Square root of x squared is x, and it just so happens that the square root of -1 is actually equal to, the square root of -1 here is equal to plus or minus I. Because really, when we took the square root, we had plus or minus the square root of -1. So x then equals plus or minus I. So in essence here, what this means is that we don't have any real solutions, no real solutions. When I say real, I'm talking about real numbers. So no real solutions. But there are zeros in the complex number system. And that's where I said, like I said, that video kind of talks you through like what is the complex number in the what is the complex number system? Complex number system. Kind of gives you also the where it's used in terms of physics, engineering, radio waves, and so on. Okay. All right. So just below that, your fact, an imaginary number I is defined as follows. I is equal to plus or minus the square root of -1. Therefore, I squared, think about it. Well, if I is the square root of -1, then I squared would be the square root of -1 times the square root of -1. And anytime you take a square root and multiply it times itself, you just get what's inside, okay? So I squared is equal to -1. All right, so then let's come on down here to example 2. I'm going to do A, B, and C here with you in the video, and then I would say pause the video and you try the next 3. On that first one, the square root of -9. I'm just going to take a moment and burn an extra step here. Think about this square root of -9. Couldn't we say that this is the same as 9 times -1? Right? This the square root of -9. Well, 9 times -1 still equals -9. Now think about what you know. The square root of 9 is 3, and the square root of -1 is I. So that would be your final answer, 3i. All right, on your next one, you have -4 on the square root of -32. And let me back up for a second. I think of that you're going to get to a point where anytime you can take a perfect square root, you're just going to automatically say, okay, well, I know the square root of 9 is 3, and because it's a negative underneath that square root, I'm automatically have to attach an I to it. And you won't have to continue to put the -1 times the numbers and so on. Here you already have a negative on the outside, so just bring it down. -32, I need to reduce it, so I think for the highest number in my list that will go into 32 evenly, so hopefully you agree with, oh, 16 can do that, so I have -16 times 2, that would give me -32. So now I'm bringing down my negative. The square root of -16, so because it's square root of 16 we know is 4, because it's negative we say it's 4i, and then we leave the square root of 2 inside. Now, I'm okay if you leave it like that, but I know that you'll be taking your that if you had to put it into MyLab Math, I'm fairly certain they want it in this form, -4 square root of 2i on the outside. They're going to want it like that. Either one is fine with me, but just so you know, MyLab Math, I'm pretty sure wants this latter one here, okay? And I'll box both of those in. And then the last one here that I'm going to work with you, the square root of -31, we can reduce this. You wouldn't say it's already simplified, because think about that. I can say that -31, that's the same as -1 times 31. And I can pull out the square root of -1 because we know the square root of -31, or the square root of -1 is I. So you can write it as I square root of 31, or MyLab Math is going to want the square root of 31 and I. Just be sure that I is not underneath the square root. Okay? Again, pause, you try D, E, and F. All right, so we'll pick up down here with the pattern associated with I, the imaginary numbers. As you see here, I is equal to the square root of -1. We've already established that, so I is equal to the square root of -1. We've already also established that I squared is equal to -1. Now you'll notice the next one, I cubed. Look how I wrote that. I cubed, would you agree that's the same as I squared times I? Well, we know that I squared is, so I'm gonna come over here, that I squared is equal to -1 times I, so that would give me -I, right? And then, so we know, okay, now we know that I cubed is equal to -I. And then let's look at I to the 4th. I to the 4th, would you agree? I could write that as I squared times I squared. So think about that. Well, I squared is -1 times another -1. A negative times a negative gives us a +1. So I to the 4th equals +1. Now notice what happens whenever I look at I to the 5th, 6th, 7th, and 8th. Since I to the 4th is equal to 1, then any multiple of 4 is always going to go to 1. So when I rewrote I to the 5th, instead of writing it as I cubed times I squared, I wrote it as I to the 4th times I, because we know this I to the 4th is just 1. So 1 times I is I. When I get down to I to the 6th, go for I to the 4th, okay, because we know that's 1. 1 times I squared is I squared, and we know that I squared equals -1. I to the 7th is I to the 4th times I cubed. Again, this is 1, so 1 times I cubed, we know I cubed equals -I. And then likewise, when I get down here to I to the 8th, I to the 4th times I to the 4th, so 1 times 1 is 1. They always repeat in cycles of 4. So for example, if I asked you I to the 18th, then I would think of the highest multiple of 4 that would go evenly into, that we could go evenly into 18. So I would say, okay, well, I to the 16 times I squared, right? Because these two, when you multiply these two, you add your exponents. So these two need to add up to 18. Because remember, this I to the 16th is the same as I to the 4th to the 4th, all right, times I squared. So this I to the 16th is just 1. So 1 times I squared. And so then that we know I squared equals -1. Now, you know what, I just thought about it. I should show you where I is on your calculator. So let me minimize this. Let me pull up my calculator. There it is. It takes it a minute. I should have grabbed it sooner. There it goes. It's nice if you can remember where those I's are, what those I values are, but if you can't, I just want to let you know, hey, you don't have to memorize that. To find your I is down here at the decimal point, down here at the very bottom of your decimal point. So you hit second I, and then you want to raise it to the second power. Tells you it's -1. Second I, and you raise it to the third power. Tells you it's -I. And then second I, raise it to the fourth power. It tells you it's +1. Now, if I did that same problem where I did second I and I raised it to the 18th, it gives me my answer. If I do, as we get higher, I just want to pick another number. Let me say I do the 89th power, for example. So maybe this is a glitch that the calculator has finally worked out. Okay, there we go. I knew. Okay, so evidently it's working better than it used to. For really high numbers, you can see it gives you this wonky answer here. This is not the correct answer. We would still need to think about the highest multiple of 4 that would go into 402. Okay, so I just wanted to bring that to your attention, that you do have the calculator that can help you. Just hit your second, and then your decimal brings up your I, and raise it with the caret over here on the right underneath your clear, and put that power in. All right, let's go back to the notes. Let's flip it on over, actually. Top of the next page, they say use your patterns associated with I to find the following. So I'm going to do letter A and letter D with you. Okay, so for the first one, letter A, I have I to the 37th. So I to the 37th, I think of the highest multiple of 4 that will go into 37. So I know that, okay, 4 times 9 is 36. So I to the 36 times I. So that would be like I to the first power. 36 plus 1 gives me I to the 37th. So I know I to the 36, since that's a multiple of 4, then this is just 1, and 1 times I is I. So that's your final answer for that first one. Calculator may or may not have done that one. We know calculator is not going to do letter D out here, I to the 401st, okay? So I think of the highest multiple of 4 that will go into 401, and so I can think, okay, well, 400. So I to the 400th times I, right? I to the 400th, because remember, it's 400 plus 1, that gives me 401. So I to the 400th, we know 4 times 100 is 400. So this is a multiple of 4. So this is just 1 times I. So that gives me I. Final answer. They're not always I. I should have pointed this out on the previous page. All of your answers to these problems will either be I, -1, -I, or +1. Okay. And if I go back on the previous page, you can probably see it better, more in concrete terms. Back over here, you can see that your answers are either going to be I, -1, -I, or +1. Those are your 4 answers. I, -1, -I, +1. 4 possible answers. All right, then we'll go back over to that next page. And at the top in example 4, I will now look at, actually, let me skip, I didn't want to skip this up here. The complex number is of the form A plus BI. A stands for the real part, and the B is the imaginary part. You're going to always treat I like a variable when you're performing your operations, okay? So sort of treat it like X. I'm going to do B, C, and D of this example with you, okay? So in letter B, you essentially here you're taking your first parentheses and then you're subtracting the second parentheses. Remember that this is a -1 that needs to be distributed to that entire parentheses. So I'm just going to burn an extra step here. So I have -17 plus I in the first parentheses, -1 times -2. I'm just going to change this to a positive. So then -1 times -2, that'll be a +2. -1 times -5i, positive 5i. Okay. Once you distribute that -1 through there, then you can change your middle sign here to positive. And now you're just combining like terms. Combine your real terms. -17 plus 2 gives me -15. Now combine your i's. I plus 5i would give me 6i. Final answer. -15 plus 6i. All right. In letter C and letter D, you are multiplying here, and so this will be where we use our FOIL method. Okay, so in letter C, I multiply the first. 1 times -2, so the first. 1 times -2 will give me -2 first. Outside, 1 times -6i, minus 6i. Inside, negative times negative, so that would be a positive 2i. And then last, negative times negative gives me a positive 6i squared. All right, I usually burn a few steps here. So I'm going to bring down my -2, combine like terms. So -6i plus 2i gives me -4i plus 6i squared. Now think about what we know at this point. We know that I squared is equal to, if you don't remember, look back on your previous page, what's I squared equal to? I squared is equal to -1. So now, what I did is I just rewrote that and just put in place of I squared, I put -1. So now I'm going to clean that up. So now I have -2 minus 4i, positive 6 times -1, -6. Like I've been saying, let your operations determine your sign. Don't do double signs. Now from here, combine like terms. -2 minus 6 lands me at -8 minus 4i. So -8 minus 4i, final answer. If you feel good about that one, go ahead and pause the video and try letter D on your own. I'm going to go ahead and talk you through it though as well. All right, so I'm going to FOIL here. Multiply my first. -2 times -2, that's going to give me a positive 4 first. Outside, -2 times -7i, so plus 14i. Inside, 7i times -2, -14i. And then last, 7i times -7i, -49i squared. All right. Now from here, notice what happens to your 14i's. One's positive, one's negative. They're going to cancel out. So I have 4 minus 49, and here again I've got it times I squared, and we know I squared is equal to -1. So now I'm just going to bring it down another step. -49 times -1 gives me positive 49. Add together, get a final answer there of 53, a positive whole number. Okay. That last example there is referred to as what we call, they're referred to conjugates of one another, because you notice that the terms themselves are the same. The only difference between the two of them is the middle sign. One's positive, one's negative. So that's those are referred to as conjugates of one another. A complex conjugate, if a plus bi is a complex number, then a minus bi is its conjugate. So that's what you're seeing here. They're complex conjugates. The product of two complex conjugates will always equal a real number. So that's what you were seeing here in this example, that when you multiply them together, you are always going to get a whole number at the end. When you're simplifying your quotients, you cannot leave I in the denominator. That's something you'll hear a lot of if you're going to take a trig, okay, in calculus. All right, I'm going to let you do A and B on your own. I think those are very self-explanatory from what I've already shown, and they're also fully worked out on the solution key. I'd like to work C and D in the video here with you. So in letter C and letter D, I'm going off of this last note where it said I can't leave I in the denominator. So in order for me not to be able to leave I in the denominator, I'm going to utilize the complex conjugate. I'm going to multiply by my conjugate here, and that way I know that when I multiply by my conjugate, that it's going to get rid of the I in the denominator, because it's going to leave me with a whole number in the denominator. So whatever you do to the bottom, do to the top. So remember, the only thing that you change is that middle sign. So this will just turn into 5 plus I. Just do it to the top and the bottom. And then it just turns into foiling on top and bottom. So up top, you're foiling 2 plus 3i times 5 plus I. So we do our first. 2 times 5 is 10. First, outside, plus 2i. Inside, plus 15i. Last, plus 3i squared. What happens on the bottom? 5 times 5, 25. First, outside, plus 5i. Inside, minus 5i. Last, negative I times positive I, negative I squared. I'm going to burn a lot of steps here just so that you can see it. If you can do things in less steps, by all means, it's perfectly fine. All right, so now up top, if I'm cleaning that up, I've got my positive 10, 2i plus 15i. Of course, we know that's going to give me 17i. And then I've got my I squared up top, so I know that I squared is negative 1. So I'm just go ahead and replace that. On the bottom, I've got my 25. The positive and negative 5i's cancel out. And then I've got minus, and then I know that that I squared down there is equal to negative 1. Okay. Now, clean up again up top. This would be 10 plus 17i, 3 times negative 1. So that would be minus 3. Let that operation there determine your sign. So since it turns into a negative, I'm going to put minus 3. On the bottom, two negatives side by side turn into positive, so I have 25 plus 1. All right, so now 10 minus 3 up top gives me 7 plus 17i, and then on the bottom I have 25 plus 1, which of course is 26. It's perfectly fine for you to leave it like that. However, I do believe in MyLab Math they break it up into two separate pieces, the real part and the imaginary part. So there you're going to see them do this. 7 over 26 plus 17 over 26i, like that. Okay? If you could ever reduce these, you certainly would. Okay? So again, if you feel good about that, you might want to try letter D, at least to a point, get as far as you can, and then come back to the video if you get stuck. Okay? I'm going to go ahead and work letter D. So looking at D, again, I can't leave that I in the denominator, so I multiply top and bottom by my conjugate. Only change the middle sign, so I multiply top and bottom by 3 minus 2i. So up top, when I FOIL, first, 3 times 3 gives me 9. First, outside, minus 6i. Inside, minus 12i. Last, negative times negative, positive 8i squared. On the bottom, 3 times 3 is 9. Outside, minus 6i. Inside, plus 6i. And then last, minus 4i squared. Now, from here, we start to combine like terms. So I have 9 minus 18i plus 8. And we know that I squared is equal to negative 1. So 8 times negative 1 up top. On the bottom, I have my 9. My 6 i's cancel out. Minus 4 times I squared, I know, is negative 1. Okay, so now from here, start to clean up a little bit more. That will leave me with, let's see, I have up top 9 minus 18i minus 8 over 9, and a negative times a negative gives me a positive 4. So then we know the bottom turns into 13. And then up top, we know 9 minus 8 gives me 1 minus 18i. And then, like I said, they'll reduce it down to looking like this. 1/13 minus 18 over 13i as your final answer. But either one technically is correct. Okay? All right, I hope this helps. Let me know if you need anything. Thanks a lot. Bye.